Okay, so hello, I'm Nic Ferrier. First of all, safety checks, right? I swear really badly, and I'm really sorry because mostly I don't know I'm doing it. So I apologise if anyone's offended before I start cussing. This is about, so it's kind of interesting because it will be very contrasting to your talk. Because this is about something, you were kind of talking at the beginning of what happens at the beginning of continuous delivery. I'm going to talk about something that probably you can only do at very high maturity once you've been doing continuous delivery for a while. This stuff came out of a startup that Matt Saunders and I were in a few years ago. I have never seen anybody else do this. The reason I'm talking about it is because whenever I talk about it, people go, oh, yeah, it sounds quite good. Or they're outraged by the audacity or sheer stupidity of it. So just getting some more people to think about it would be kind of good. If you want to ask a question or throw shoes or something, well, if you want to throw shoes, could you throw them that way? But if you do want to ask a question, that normally is fine, unless it's offensive. Because, as we know, we don't do offensive things, except me. So let's, I'm going to do like that. So we're going to start off by just talking about testing, right? Because this is about testing things. Did I say that? It's about testing things. So here's the Agile test pyramid. I hope you can all see that. You were just referring to this. Unit tests on the bottom, integration tests in the middle, acceptance tests. This particular diagram seems to have allocated strange percentages. I bet there's no evidence for that. What is up the side? What is up the side? Anyone care to tell me what the axis is? Why is it a pyramid? What goes up the side? Cost, right? These things cost more to do than these things, So we make loads and loads of unit tests because they're cheaper. Right? Otherwise, these give better assurance, right? Acceptance tests, they give much better assurance that something works, right? End to end. So why wouldn't we do them all the time? Well, because they cost a lot to make and maintain and all of that. Whereas unit tests, you can get programmers to do them all the time. They get thrown away. They're much more maintainable, right? That's the theory. Anyway, everybody's kind of, some of the people are staring at me completely blankly as if, no, that's not how it works where I am. But anyway, that's the theory. There's a kind of interesting thing in here, I always think, because this covers a multitude of sins, integration testing, and actually a lot of what we call unit testing turns out to be integration testing. If you're using Rails or Django or anything like that, you're automatically doing 99% integration testing. It's got a bloody database in it all the time. So there we go with the swearing. That's sort of base swear. So this stuff, though, classically, unit tests are not supposed to have any integration in them at all. If you're talking to a database or a web server or anything like that, you are not writing a unit test, classically. Kent will come round your house and tell you off. He won't really. Pity. But integration testing, normally we can separate that into three things. We can separate that into kind of mock integration testing, where you are mocking out a web server or a database or something like that. And then we can separate it into the next layer, which is where you're actually using somebody's code that implements some service that you want to call. So it might be a real web server or a real database, and you're actually transacting with that somehow. And then there is a third thing where you're going outside of your project, as it were, to go and deal with a dependency that somebody else made. So a web server on the internet, for example, would be a good example of that. Or if you're in an enterprise, you know, some other team's madness that you can't touch. Now, one of the interesting things is that if you're only dealing with that top layer, and often you are in integration testing, you go to the team and you say, we want to do integration testing against your environment or against your code somehow. And they say, yeah, that's fine. The environment's there. You can point to it and, you know, go off and do that thing. And you say, well, isn't there anything else you can give me? Could you give me the code, maybe, so I can test it? Oh, no, we can't give you the code. As if you're going to steal it or do bad things to it. And that's kind of, I always think that kind of tells you that you can't really trust them. Because if they can't spin that up for you, if you can't take it and spin it up in a reliable way, then how are they doing it? So why should I trust the environment that you've built for me or everybody else? So that's kind of interesting. There's kind of politics and nuttiness in this bit. This bit is even worse, right? Because this gets into the acceptance testing of end-to-end stuff. This starts to deal not just with technicians, who you have to deal with a lot down here, but you have to start dealing with business people and UX people, and they're all completely mad, as we know, and a total waste of space, as we know. So anything that you do there is kind of already doomed to fail, right? So the other thing that you get with all of that is coverage. What does coverage mean? It means nice woolly blankets. I do like nice woolly blankets, and so does my cat. But it also means that this is a way of testing whether our code is good, right? How much coverage have you got? How much coverage have you got? 20%. How much coverage have you got? Less than 20%. How much coverage have you got? 50. So I deal, the team that I run where I work, which is in a really, really big bank, one of the biggest banks in the world, my team, they reckon they've got 90% coverage, right? 90% coverage. And they have, I've seen the stats. It says a 9 and then a 0 and then a percent sign. That means 90%, right? But amazingly, when we go live, sometimes it breaks. Well, we must be hitting that 10% a lot, mustn't we? Nonetheless, it's a great way to measure whether tests work or not, isn't it? Coverage, that's a great measurement. Let's move on. I think you see where I'm going. This is W. Edward Deming, who's kind of being called the father of lean or some such. He worked at Toyota in the 50s. As you can see, he's an American male from the 1950s with the spectacles to match. He came up with this idea of experiment-driven change and stuff like that, and they adopted it at Toyota and in manufacturing, and it's kind of a big deal. And we're all talking about it now. We're all talking about the lean startup and testing ideas and all those things. And the idea is that your product people should be able to come up with an idea, and you should be able to develop it quite quickly, and then you can roll it out and test whether it worked or not. And if it worked, that's great. Let's do another test on top of that. But if it didn't, let's stop doing that. So there's a simple example. I don't know why the screen is offset. I apologize for that. But we could increase the size of a add to basket button by 10%. Let's increase the size of the button by 10%, and maybe the basket ads will go up by 5%. That's what we're trying to do. Or we could just say we're trying to increase the number of people who put things in the basket by 10%, and whatever we have to do you have to make the button green and purple or flashing red? We could go back to a sort of pre-Web 2 style of HTML. That might work. So we could do all sorts of things, and maybe if we increase basket ads, maybe we can actually increase sales, for example. The other reason I really like Deming is that he said my favorite quote about organizational change of all time. He said, change isn't mandatory because neither is survival. Boom. But what is lean really? It's a way to work out what to do next as a product owner, and it's a way to stop programmers doing all that bullshit over engineering that they do. When they say quality, what they mean is sitting on their asses for 6 months talking about whether this class should be injected into that one or the other way around. I don't know if you've seen this show. Anybody seen this show? Everybody seen it? Hands up who's seen this show. No, this is Silicon Valley, which is an HBO show. It's very, very good on the subject of startups. I recommend it. Although, if you work in a startup, it's also actually don't watch it. Don't watch it. It's too true. What does lean require? This is kind of a nightmare, isn't it? It requires critical thinking. It requires critical thinking about where you are. So you can't. I've been in places where we've had a very capable development team and we've been capable of doing lean, but the product owner's insane. So it doesn't actually make any difference, right? You do have to have sensible people who are doing sensible things. And just going, but I want it that way, is kind of nonsense. I guess the answer is probably you need maturity, right, from everybody involved. you need to be thinking about where you are and what you're doing and how what you're doing makes sense and whether you could change it, and criticizing it all the time, that's hard. Critical thinking, critical thinking, I was prompted to put this on the slide because I was talking to my daughter, and I can't even remember what I was talking to my daughter about, but it was obvious that critical thinking was not being encouraged at her school, and it was a dilemma of whether to explain to her, how to tell her to explain to her teachers that they ought to fuck off, or, or whether she should learn how to kowtow. And I think that's very sad, right, that we spend a lot of time telling talented people that they shouldn't say that. Oh no, you shouldn't say that. Oh no, you shouldn't say that. Oh, don't say that to that person. Well, maybe a good dose of criticism is something that we all need. Misplaced criticism is obviously bad, and being aggressive is obviously also bad. But certainly critical thinking is not encouraged in this country, in either our schools or our enterprises particularly. I've been in loads of startups where it was great, but in our schools and large enterprises, critical thinking can get you fired quite quickly, or detention. I mean, maybe they should introduce that into enterprises. That might be an interesting approach. So the side effects of lean are big train crashes, or the people who don't like lean would have you believe that. The point of lean really is that most experiments should fail, because you should be doing lots of experiments. And if you expect all of them to work, then you're kind of not doing the right thing, right? If you're an artist, you're expecting to push the boundaries, and you don't want the public to turn around and say, oh, that's really good, because you end up on people's sitting room walls just being bland, right? You need to be challenging. Well, it's kind of the same with products and lean. You need to be pushing the boundaries, and you need to be failing a lot, more times than not. Does that mean that we have failed deployments? I don't mean that. I mean the code works, but the experiment failed, right? We increased the size of the button by 10%, and no bugger clicked it. Didn't make any difference, because what it was selling was chocolate cucumbers, and nobody wants them, right? And maybe that realization could drive back into the product team who invented the thing that is crap. You're looking for most experiments to fail. I think by this stage, some of you are wondering, what on earth is this guy going on about, and where's the testing? And I'm not going to satisfy that requirement. Because now we're going to talk about IT costs and the cost of end-to-end testing. So we were talking about the pyramid earlier on, and the top of the very pinnacle of the pyramid being really, really expensive. And let's just reiterate, how expensive is end-to-end testing? Who here has ever written an acceptance test? Right, loads of you. How many people enjoyed fixing that acceptance test like after a month? How many people enjoyed that? Yes, that's what I thought. How many people have had to fix that after a month? Yeah, that's what I thought too. So I should have done those two questions the other way around, but I think that proves conclusively that it sucks, right? And it's extremely, extremely difficult. And what do we do? The point of making these experiments, right? We're going to do some stuff. We're going to alter probably quite a lot of things in order to do an experiment, or maybe only a few. Do we write lots of Selenium tests, or lots of what sort of things? How much can we support in the unit layer to make that kind of stuff happen? And you can, if you're not mature, this can be really, really, really expensive. And if you're trying to do this in traditional ways, it's still really, really, really expensive. You have to have people who are trained just to write these kind of tests and just to maintain them. And then you have to have infrastructure just to run these tests, right? And it can be really expensive. People make businesses out of parallelizing Selenium tests. People make good businesses out of parallelizing Selenium tests. So clearly, certainly the bank I work for is pouring millions of pounds down the throats of enterprises who sell them stuff of how to do this. It's nice work if you can get it. So transactional testing, what am I talking about? I'm talking about an alternative to those millions, squillions of pounds that we spend on doing that. And it's a really, really dumb-ass simple idea. The simple idea is that you just make a tiny, tiny test just around the change that you're making to the code. And what do we do normally? When we change something, we go and write a test to test that everything around it works, right? That the whole flow of the thing works. But my idea is to say, no, don't do that. Just test the bit that you're changing. Only the bit that you're changing. So, if we change the font size of the button, let's not check that the button's still placed on the page or anything like that, because it probably is. That's probably all okay. Let's just check that we're changing the font size. That's it. That's all I'm talking about. And you're all probably thinking, oh my gosh, I've been swindled tonight, except I didn't pay. So I've just wasted my time. Oh well. So, why is this a big deal? Because then we can have lots and lots and lots of really small tests that do very small things. And together, they can assure us about stuff. So each test is very understandable. It does one thing, right? It tests something really, really tiny, and we can see clearly what it does. And you can associate it with your commits. You can make it very clear, the relationship between what I'm trying to do and what the test is. Has anybody got involved in making changes to databases? Transactional change on databases. Right. You guys done this yet? Right. I'd expect you to have. And it's kind of the same kind of things. Very transactional. You end up doing lots of small, little things. Instead of, oh, you know, we actually want this table to look like this, so we'll or the schema to look like this, so we'll totally transform it in one big job. We'll do it at the weekend, and we'll just really cross our fingers and our toes and anything else we can cross that it works. And we'll pay some other people to just sit there with everything crossed because, let's face it, it's not going to work. And so we need all of the help we can get, and we'll sacrifice chickens if we have to. So instead of doing that, what do? You make lots and lots of tiny, tiny, tiny little changes, and sometimes it takes months. I remember we did a table at WereMe, right, that was enormous, and we also had a kind of crazy batshit German DBA who was the most un-German person you've ever met. Right, you'd expect, okay, so this is a stereotype and probably racist, but in my experience, and I have worked in Germany, right, they are very, very good at being meticulous. And there is something about being German that is about being meticulous and careful. And Frank, my DBA, was fantastically disregarding of any kind of care whatsoever. Let's do it. Did you test it, Frank? No, but let's just go. So making database change with Frank was always really good fun. So how do you manage these? If you have loads and loads and loads of these, right? Because that's one of the problems. We're going to have to manage them. And right now, we just said that this is a nightmare. That whenever I go back after a month, I can't understand what it is, and I have to go and change it, and I end up with 20,000 tests. There's another team that I work with at the bank who've got 20,000 acceptance tests. 20,000! Can you imagine? What do you do when one of them breaks? Oh, we go and fix it. Yeah. What's your cadence? About 3 months. Yeah, I bet. So what do you do instead? If you've got loads and loads and loads, if you increase that exponentially by making these things so granular that it's nuts, so what do you do instead? You throw them away. When you've finished using it, you made that change. It was done. Why do you need to test it again? Are you going to go and change that same line of code next week? Nope. When you do change that line of code, make another test. And maybe you could keep these in source control somehow. Maybe you're not going to throw them away completely. Throwing anything away is always a bad idea. You don't want to see my house. So maybe we don't throw them away completely because it's really easy to look after things that are inside computers. But you don't want to run them because that's the expensive bit. So stop running them. But when you need that thing again, maybe you could go look at it and say, what did I do last time? Last time we changed the Frobnicator in this way to increase the blue. What did we do to test the Frobnicator? was more blue. Oh, we did that. Oh, okay. Let's maybe do the same thing again. You might even resurrect the exact same test, right? There's also this thing about how to make this work. What you could do is just deliver one change to production at a time. Just one. So this tiny little change, just push that out. See if it works. What are the implications of this? The first time I saw this image, right, it was last year at Easter, and it was like, hold on to my eggs till Monday, which I think is really, really cool. The implications of doing this, why would you do this? It creates a really tight loop between dev and testing. In the same way that unit testing creates that tight loop, you start creating that tight loop around the whole thing that you're doing between dev and testing. The end-to-end tests start to look like unit tests in terms of cost, right? And what did we say right at the beginning? We said they are the most important thing, but they're really, really expensive to do. They give us the most value, but they're the most expensive. But if we could reduce the value somehow, the expense, that would be funny if we reduced the value. If we could reduce the expense somehow and retain most of the value, why wouldn't we do that? It also creates very tight communications between what the test is and what the program is. You start making contracts between what the test code is and what the program does. So we do this in normal testing, or nearly everybody put their hand up to acceptance testing. So most of you have probably built page objects and stuff like that you use to drive Selenium tests. But this stuff, if you're doing this stuff, this makes those contracts more and more granular. And what do we know about granularity? Granularity is good, right? We seek it all the time. We seek to do more things more often because it's more granular. We seek microservices because it's more granular, because that means we can maintain them. Why do we not do that in human problems? We don't do that in human problems when it becomes more difficult to manage the granularity. One of the things that you said was really interesting, that I've had for years and years and years and years, is people resisting continuous delivery by saying, oh, but it'll be more complicated. When did things ever get simpler? Right? When did that happen in computers? When? Name one bloody time when life got simpler for us, right? So why resist things on the basis of complexity? You are basically King Canute. Everybody remember King Canute? Right, he sat in a chair at the edge of the beach and told the sea to go away. It didn't work, right? Neither will resisting complexity. You have to embrace complexity because it's gonna happen, right? So instead of saying, oh no, it'll be more complicated, of course it'll be more complicated. Deal with it, deal with the complexity, work out how to make it more complex manageably. Have I done this? So I've already mentioned that Matt and I were in a startup called WereMe, which was kind of a nightmare for all sorts of reasons, but technically I feel like it was a bit good, right? But we did struggle. We had an insane product manager. This was a guy who, he asked me to do just a little story, right? He asked me to do a feedback link. Can we put a feedback link on the site? You know, you press this button, you get feedback form, you type in, oh, I hate this dating site, it's rubbish, right? And then press the button and it submits it. And then we can review the feedback a lot, right? Because it's good to get feedback from the users. Yeah, sure, I'll do that. So it's Friday night. I had a new child, so clearly I wasn't going to go out. So I did this thing, implemented it, took me, 6 or 7 hours, nightmare code base, blah, blah, blah. Anyway, it was done. I rolled it out. He came back from a restaurant and went absolutely mad because the form didn't have rounded corners. So he was kind of one of those guys, right? He was very, very interested in making sure that it was absolutely perfect, this stuff, right? And so consequently, can you imagine being a tester working for somebody like that, right? It's not right! That the third pixel from the left is the wrong color. And he was brilliant, this guy, at that kind of stuff. He was absolutely brilliant, but he did kill testers by the legion. Right, we'd hire them. Oh yeah, it's a great place to work. Startups, really, fantastic. Lots of technology, dating. It's a very interesting game. Blah blah blah. And here's your boss, and he's very charismatic. Fantastic, yeah, brilliant. 3 weeks later, so we struggled with testing for a long while, and in the end, I just said, look, okay, we're not going to have any more testers. We're just going to write code to do the tests. No more. You're not going to be allowed to do any manual stage. We will just go live with an appropriate suite of functional tests. And we replaced 2 professional testers within 3 months with just me writing tests, part-time, because I was a CTO, so I had other things to do, and I had code reviews to do. It wasn't like I was doing this 50% of my time. It was maybe 15% of my time. So we did 8,000 releases in WereMe, so we also weren't doing a small amount of change. It was a lot of change. But we replaced these 2 pro testers. So there you go, another stat, right? 8 strong tech team, at least 10 changes a day. And we replaced these 2 testers, 2 pro testers, with just me writing the tests. So that's kind of compelling. We managed to do that because I did it like this. I broke the change down into lots and lots and lots of small chunks, forced the developers to write lots of really small things, not as small as I'm talking about here, but why not go the whole hog? And we had good flow. So, Salvador Dali, right? Do we not need testers anymore? Loads of people, when I talk about this, a lot of people get really excited. We don't need testers anymore. That's great, isn't it? Let me tell you an anecdote about one of the guys in my bank. They were doing a big town hall thing, loads and loads of people. And this guy is the head of, I can't tell you where because it would kind of give it away, but he's the head. He's a very senior guy. So he's doing the town hall, and then a whole bunch of questions from the IT people. And the person who runs testing in the IT function put her hand up. Do you agree that testing is undervalued? And he went, absolutely not. Testing's bollocks. Every time we go live, it still breaks. So what are you doing? I just thought, wow, marvelous. We just need more people like that. But we also need testers, right? Why do we need testers, though, if they're not writing big Selenium tests all day? What could possibly they be doing? Well, they could be getting involved earlier and thinking differently about the code, doing what they're actually supposed to be doing. If you go and read any of the books about Agile and how to do software delivery, what they all stress is that testers should be involved in the production of code, not just in the bit afterwards, right? Just as the product people shouldn't be involved just at the beginning and at the end to go, oh, what you delivered didn't really, no, it's not what I wanted. No, involve everybody all the way through, including the testers. And why is that? It's because testers think differently to programmers, right? I'm a programmer. I want my code to work. So often, being absolutely honest, often, not even sometimes, often, I lie about the quality of my code. It's just what we do. I don't know how many of you are programmers, and I'm not going to ask you this question, but I can stand in front of you with my hand on my heart and say, I absolutely do lie. If I catch myself, if I realize what I'm doing, I will often then go, oh, wait a minute, I'm lying, sorry. No, it is shit, you're right. But there are plenty of times when I catch myself out. That's just human nature. I'm a programmer. I want it to work. Testers want it to fuck up. That's what they want. You need people like that. You need that kind of what is the word? Tension, right? So we still need testers. Oops. Especially for things like that. If we're doing all this stuff, do we ever need to write normal tests? Wow, it's interesting, because at WereMe we had 2 full stack tests, proper big stuff that looked like normal Selenium tests. Out of thousands of tests, we had 2 that looked normal. And they were registration and payment, i.e. the critical, absolute, the stuff I was going to get fired for if I fucked it up. Absolutely, you know, if I broke this, I was going to look a complete muppet. So we had proper full tests around that. Now, I don't know whether that was just because I am a lily-livered, yellow-bellied coward and should have had the courage of my convictions, or if it was a sensible thing to do. It feels to me like if you absolutely have got something like a regulator says to you, this must work all the time, and if it doesn't, you're going to jail. Well, maybe I will get off my arse and write a proper test, right? Or the whole thing that absolutely tests this thing all the time and guarantees that it works. Or if you're going to kill somebody if it doesn't work, that might also be worthwhile to go and do, right? But very rarely are we actually in that position. And then transactional change, layering change on top of change on top of change, might be a much more acceptable way to do it. Is it safe? Who's seen this? Everybody seen this? Nobody get the reference? Anybody? Who doesn't get the reference? Who doesn't get the reference? Oh, you need to go and watch this film. This is Laurence Olivier, but he's really a Nazi. Is it safe? How do we deal with remembering what we changed in terms of source code? We make transactional change, don't we? We record diffs, one on top of the other, on top of the other, on top of the other. And it sometimes means it's really hard to find the particular state of a particular revision because you've got merges and stuff like that. It can take hours, actually, to recover a particular state of a particular repository. I remember working with a tool called Darks. Has anybody heard of Darks? Right, Darks is a version control system built out of Haskell. And there's this thing about version control. It's actually, there's some physics behind it, right? Some interesting maths. I don't know why this guy calls it physics instead of maths, but it's provable that version control works. And this Darks thing was written in Haskell as a kind of expression of this physics of version control, but it had bugs. Who'd have thought? Haskell code with bugs, what a surprise. So it kind of blew up on me several times, and it took me days to recover a point of history. But nonetheless, I could recover it, right? So it was a lot of effort. But this is conventional, so we all just accept that this is how to do it. Those of us who are dealing with pipelines and stuff like that, where we have to go and find a particular revision to prove to an auditor that something worked at a particular time, sometimes have to spend some time going to find it because of merges and all that crap. But nonetheless, we know that it's there. The thing about doing change on top of change on top of change on top of change is maybe we could build a similar physics, right? Now, I'm not saying that it is there, but maybe just by recording the most granular thing that we could do, a bit like diffs do, then maybe that's a way to do it. Maybe we could actually start to prove that what we're doing was sensible. This is also from Marathon Man. So you start to increase the amount of transactional change. In other words, small things that are layered on top of other things. That seems safer to me than doing great big blobs of change, right? You start to roll out pieces of code that are totally hidden. Because actually, if you want to roll out lots and lots of small things and go really fast, most of your code isn't finished yet. So you start having to find ways to get the code onto production quickly, even though it's not done. Now that's very safe, right? We've got toggles and ways to do that are perfectly fine. Although, so I was having an amusing conversation at work today about, well, there's a guy in Change who thinks that toggles are bad because why would you roll out code to production that can't do anything, right? But that's a fundamental misunderstanding of how the way machines work now, because even the processor, let alone the JVM or any other abstraction that you've got sitting on top of the processor, will make most code that is branched off with nulls, it'll just disappear. It won't even get into the processor. And even if it did get into the processor, it wouldn't get turned into anything meaningful ever, right? Because that's the way processors work now. So some of these people need some technical sympathy, some mechanical sympathy. But it should be totally safe to do this. You're also able to deliver code that is deliberately turned off, but you're still going to run because you're going to target it with some particular code path on production that is only going to test it shallowly. So it knows that it's in test mode, and it's not going to go and talk to its dependencies, for example. So you get to test on production in a shallow way just a bit of the code. All of this is driven by doing code more transactionally, more granularly. Circuit breakers too. Circuit breakers provide that confidence, right? So instead of having a shallow thing where you tell the code to turn something off, you could have circuit breakers and turn them all off. So, for example, I'm working on a big database thing. It's a bit of a nightmare because it falls over all the time, even though it has 90% coverage. But one of the ways that we're going to fix it is to set up another one alongside it. Now we can run changes into that, and we can carry on running this one, and the code can change here, blue-green, right? But how are we going to make sure that the updates that are going on here can get into this one? Well, we've got a queue between the two. We can turn that queue off while we go and update this one, and then turn it back on if we're sure that this one's working. Right? So we've got a circuit breaker. Circuit breakers just mean shallow testing. You start to blur the lines between what your environments are. One of the things about testing, particularly things like acceptance testing, is it's not just the cost of writing the Selenium test or whatever you do. It's the cost of all the environments you need to make that stuff work. Oh, we need to have another gate before we go to production, and it takes 3 hours to run the Selenium tests. So if 2 people want to go and test at the same time, now you can only do 2 in a day. Oops, that's going to slow you down. If you've got 10 teams, but you can only run 2 production tests in a day, oh, so let's build another environment. Oh, that's great, because we've got endless operations people who can just manage these environments and keep them all the same. Oh, wait, no, we haven't. We fired them all. Oops. One of the things that you do when you get more and more granular change is that you stop worrying about, oh, well, what's the environment? Because you can see what the impact of the change is, right? It's tiny. You can see this thing. You can construct an environment in a much easier way. You could construct it inside a Docker, or you could construct it inside a JVM, or wherever. It just gets easier to make an environment that will be a valid place for that change to be tested. So I'm jumping around a bit, but what are the requirements for getting this kind of test maturity? Because you can't do this. You couldn't jump to this. Maybe you folks can't even jump to this, right? It's maybe going to take you even longer. A big enterprise, I think, is going to struggle to do this, even with some continuous delivery. So what are some of the things that you would need? You need a single line to production. I don't believe you'd be able to do this with feature branching, for example. You need that level of discipline and control over what you're doing, which is hard, right? So it's toggles, all that sort of stuff. You need very, very fast deployment. You need to be able to do the blue-green thing very, very quickly. You need to be spinning things up rather than keeping them there. So spin up, switch over, spin up, switch over, spin up, switch over. Obviously, you're throwing away the ones that you've finished with. That needs to be really, really fast. You need to be able to get to production in minutes. Because if you do bugger something up because your testing's all shallow, you need to respond quickly. A little bit of story about what's that Trello. So Trello is run by one of the guys, I've forgotten, Spolsky, right? Joel Spolsky. And Joel Spolsky is kind of one of the fathers of testing, right? He went on and on and on about testing in the 90s, about how to do testing this way and how to do testing that way. And his company, they do a whole bunch of stuff, and they started to get into the internet. So he did this thing, he formed this little team, and they went off and made Trello. And Trello's kind of cool and internety, and it's all kind of cool. And Joel sort of pats it on the head. Oh yeah, it's really, really cool. There's a really good story about fairly early days of Trello. And Joel rocks up. You know, it's live. It's been live for a while. And it's successful. And Joel rocks up, and it's like, okay, so guys, tell me about Trello. Yeah, this is really cool. So now tell me the testing story. We don't really have any tests, Joel. What? You don't have any tests? I'm like the father of testing. How can you not have any tests? Well, we just sort of fix it if it breaks. As far as I know, they still do that, right? And he had to suck it up because it works, right? Why can they do that? Because they go really, 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 really fast. So if they break it, they fix it in minutes. That seems reasonable to me. And also, nobody dies if they do break it. So what does that mean? Rapid deployment, you've got to have containers. You might be able to do it with the JVM. We did it at WereMe with Python, though, and Python's not very JVM-y or containery, so it is doable. You've got to have control around your release process, particularly if you're trying to do it in a regulated environment. You've got to understand what you're releasing, when you're releasing, and what you did yesterday, and the day before that, and the day before that. In part, so that you can go back and say, oh, when we did that change before, what was it? Oh, it was that, okay. So a lot of people, they have continuous delivery, and they have version control, and they have all those things, and they forget about managing releases. We release these two things together. That's important information. Fine. So nobody's asked the question through the whole thing, and it's kind of batshit, so I expected shoes to be thrown, but now's your opportunity. Thank you very much.